everyone, I'm Sandra Bullock, and today we're diving into the fascinating world of bioengineering. This field is changing the face of medicine. It's giving us new ways to heal the sick and even enhance our abilities. From growing organs in labs to editing our DNA, the possibilities seem endless. But with these advancements come big questions. How far is too far? And who gets to benefit from these technologies? Join me as we explore the breakthroughs and the ethical dilemmas of bioengineering. It's a journey into the future of health and what it means to be human. One of the most exciting areas of bioengineering is the creation of artificial organs. Imagine a world where no one has to wait for a transplant. That's the promise of this technology. Scientists are now using 3D printers to create organs like hearts and kidneys. These organs are made from the patient's own cells, which reduces the risk of rejection. This technology is still in its early stages, but it has the potential to save millions of lives. It's a testament to the power of bioengineering to solve some of our most pressing medical challenges. Bioengineering isn't just about building new organs, it's also about repairing our own. Scientists are now developing gene editing technologies that could cure genetic diseases. One of the most promising tools is called CRISPR. It acts like a pair of molecular scissors, allowing scientists to cut and paste DNA with incredible precision. With CRISPR, we could potentially correct genetic defects that cause diseases like cystic fibrosis and sickle cell anemia. It's a revolutionary technology with the potential to transform medicine. CRISPR is a game-changer in the world of genetics. It's faster, cheaper, and more accurate than previous gene editing methods. This has opened up a world of possibilities for treating diseases. Clinical trials are already underway using CRISPR to treat cancer and blood disorders. The results so far have been promising, giving hope to patients who previously had few options. The potential of CRISPR goes beyond treating diseases. It could also be used to enhance crops, develop new biofuels, and even control mosquito populations. Section 5. The promise and peril of gene editing. While the potential of gene editing is enormous, it also raises ethical concerns. One of the biggest worries is the possibility of unintended consequences. Editing one gene could have unforeseen effects on other genes, leading to new health problems. There's also the risk of creating designer babies with specific traits, raising concerns about genetic inequality. These ethical dilemmas are complex and require careful consideration. It's crucial to have open and honest conversations about the potential benefits and risks of gene editing before moving forward. Section 6. Enhancing human potential. Bioengineering isn't just about curing diseases, it's also about enhancing human capabilities. From exoskeletons that give us superhuman strength to brain-computer interfaces that allow us to control machines with our minds, the possibilities are astounding. These technologies have the potential to transform many aspects of our lives. They could help people with disabilities regain mobility, assist workers in physically demanding jobs, and even enhance our cognitive abilities. However, the idea of enhancing human capabilities also raises ethical questions. Who will have access to these technologies? And could they exacerbate existing social inequalities? Section 7. Merging man and machine. One of the most futuristic applications of bioengineering is the development of brain-computer interfaces, or BCIs. These interfaces are at the cutting edge of technology, merging the biological and digital worlds in ways that were once the realm of science fiction. These devices allow for direct communication between the brain and external devices, such as computers or prosthetic limbs. Imagine a world where your thoughts can directly control machines, bypassing the need for physical interaction. This is not just a dream, but a rapidly approaching reality. BCIs work by recording brain activity and translating it into commands. Electrodes placed on the scalp or implanted in the brain pick up neural signals, which are then processed by sophisticated algorithms to interpret the user's intentions. This data is converted into digital commands that can control various devices. This technology has the potential to revolutionize how we interact with the world around us. From healthcare to entertainment, the applications are vast and transformative. In healthcare, BCIs can help restore lost functions to individuals with disabilities, offering new ways to interact with their environment. Imagine being able to control your computer or smartphone with your thoughts, eliminating the need for keyboards and touchscreens. This could lead to more intuitive and efficient ways of interacting with technology, making it more accessible to everyone, including those with physical limitations, or having a prosthetic limb that feels and moves like a natural one. Advanced prosthetics controlled by BCIs can provide a level of dexterity and feedback that closely mimics natural limbs, greatly improving the quality of life for amputees. These are just some of the potential applications of BCIs. The future holds even more possibilities, such as enhancing cognitive abilities, creating new forms of communication, and integrating human consciousness with artificial intelligence. As research and development continue, the line between man and machine will blur, leading to a new era of human augmentation and technological symbiosis. Section 8. The Ethics of Enhancement. The idea of merging humans and machines raises profound ethical questions. As we stand on the brink of a new era, where the lines between human and machine blur, we must ask ourselves, what are the moral implications of such advancements? What does it mean to be human in an age of such powerful technology? The essence of our humanity is being challenged and redefined. Are we enhancing our capabilities or losing a part of our soul in the process? And what are the implications for society? The integration of advanced technology into our daily lives could reshape our social structures, our interactions, and even our values. How do we ensure that these changes benefit everyone and not just a select few? Some people worry that these technologies could be used to create a two-tiered society, where the wealthy have access to enhancements that the less fortunate do not. This could exacerbate existing inequalities and create new forms of discrimination, with those who can afford enhancements having an unfair advantage over those who cannot. The gap between the haves and the have-nots could widen even further. This raises questions about justice, equity, and the kind of world we want to live in. Others fear that we could lose our humanity as we become more reliant on technology. The more we integrate machines into our bodies and lives, the more we risk losing touch with what makes us uniquely human: our emotions, our creativity, our ability to connect with one another on a deep personal level. These are important questions that we need to grapple with as we continue to develop these powerful technologies. The ethical considerations are complex and multifaceted, requiring input from scientists, ethicists, policymakers, and the public. It's crucial to ensure that they are used responsibly and ethically. We must strive to create guidelines and regulations that protect individuals and society as a whole, while still allowing for innovation and progress. The future of human enhancement is not just a technological issue, but a deeply human one. Section 9. The Future of Bioengineering. The field of bioengineering is rapidly evolving, with new discoveries and innovations emerging all the time. This dynamic field combines principles from biology, engineering, and technology to create solutions that can address some of the most pressing challenges facing humanity today. From developing new medical treatments to creating sustainable agricultural practices, bioengineering is at the forefront of scientific advancement. The future of this field is full of promise and potential. Imagine a world where we can grow organs for transplants, design microorganisms to clean up environmental pollutants, or even enhance human capabilities through genetic modifications. These are not just science fiction fantasies, but real possibilities that bioengineering is bringing closer to reality every day. From curing diseases to enhancing our abilities, bioengineering has the power to transform human life in profound ways. For instance, advancements in gene therapy are offering new hope for patients with genetic disorders, while tissue engineering is paving the way for regenerative medicine. These innovations could lead to longer, healthier lives and a better quality of life for people around the world. However, it's crucial that we proceed with caution, carefully considering the ethical implications of these powerful technologies. The potential to alter the very fabric of life raises important questions about the limits of human intervention in nature. Issues such as genetic privacy, consent, and the potential for unintended consequences must be thoughtfully addressed. As we venture further into the world of bioengineering, we must remember that with great power comes great responsibility. It is essential to establish robust ethical guidelines and regulatory frameworks to ensure that these technologies are developed and used in ways that are safe, equitable, and beneficial for all. It's up to us to ensure that these technologies are used for the betterment of humanity and the planet. This will require global cooperation, interdisciplinary collaboration, and a commitment to sustainability. By working together, we can harness the power of bioengineering to create a brighter, healthier future for generations to come.